walked off. So we talked about how 2.5 are just reflections of each other, because a half can be written as 2 to the negative 1. So basically what you need to take home from exponentials is if b is greater than 1, you get the shape above. This is called an increasing exponential function, or a growth function. And we talked about this. That's why we did the word problems first before we actually do the graphs. You're supposed to do the graphs first. It's the very first lesson. I never do it first. I do it after you've actually learned stuff, and then it makes more sense rather than memorizing. But when we looked at word problems, we looked at something like, I'll use the same actual letters we used. So we did like final equals initial, and then we put a 2 in here, and then it was to the t over p. And when we put a 2 in, what was it doing? Doubling. Okay? Swap the 2 out, put a 3. What's it doing? So it's increasing, still growing, right? The 3 just makes it grow faster, right? If it triples, it grows faster. If it doubles, it grows a little less fast, right? Okay? We also did final equals initial, and then we did like 1.4 to the x. What was that one doing? It was increasing, appreciating, 40%, right? So it's still increasing. Is this one increasing as fast as the doubling was increasing? No. And the tripling? So the larger your b value, the faster it increases actually, right? Because you're growing at a faster rate. This one's growing at 40%. This one's growing at 200%. This one's growing at 300%, right? Like they're growing substantially. So when your b is greater than 1, the function is growing. We agree? So let's look at these ones. So here we have 3 to the x. What is the value of your a? Remember the format is y equals a b to the x. What is your a in this one?
1.
It's a 1. Can I just put these two numbers together? Never. Right? You can only put them together if they have common base. So it was like 3 to the 2 times 3 to the x, and I can put them together. So my value of my a is 1. The value of my b is 3. So it's increasing, right? Do not write it like this on a test. I'm being lazy. I'm lazy in my notes. I'm not allowed to be lazy on a test. I have to write increasing, right? Not arrowing, which arrowing upping is what it looks like too. Yeah.
So if we were asked for the value of b, we would need to specify 3 and
Nope.
increasing.
3.
Just 3.
Yeah. This is like a caveat. If it's 3, it is increasing. The value of b is just 3. Y-intercept. The moment you hear y-intercept, you just think x equals 0. Okay, well, let's do that. So we have y equals 3 to the 0. What is 3 to the 0?
1.
1. So my y-intercept is at 0, 1. Remember that y-intercepts and x-intercepts are coordinates, not just a number. What's the y-intercept going to be for all of these?
1.
Why?
Because all of them are just one is the power of x without any translation.
Exactly. So I'm going to get, this one's going to be 4 to the power. What? Thanks, board. 4 to the power of 0, which is 1. And then this one is 5.25 to the power of 0, which is still just 1. So the value of a in this one is a 1 and a 1. That didn't change. The value of b for this one is 4. So it's actually growing faster than 3, right? And then this one is 5.25, which is growing faster than 4 and 3. Because 3 is 300 times, 4 is 400 times, 5.25 is 525 percent growing, right? So how do the different bases affect the function? Yeah, so the greater the base, the base being b is greater than 1. It has to be greater than 1, because if it's not greater than 1, it's decreasing, right? And you can't say that, I guess. You have to say between 0 and 1, it's decreasing. So the greater the base, b is greater than 1, the faster the function increases. I actually find this lesson a lot easier to understand if you know your word problems, because your word problems kind of set you up for whether it's increasing or decreasing off of your b value. Okay. What's happening now? The board is being stupid. But besides that, what's happening now? My a is changing, but my b is staying the same. The value of b for all of these is what? 2, which means the graph, why does it hate me? Why? Okay, so the value of b is 2, which means all these graphs are doing what? Pardon? Yeah, they're doubling and they're increasing, every single one of them. The only difference is the a value has changed. So the a value on the first one is 1. On the second one, it's 3. On the third one, it's 4. On the fourth one, it's 5.25. Now, can I put the 3 and the 2 together and say 6 to the x? No. If you can stop yourself from doing that, you are in a much stronger position than the rest of the people who are going to multiply those. Make sure you're paying attention. So 3 times 2 is not 6 to the x. This is 3 times 2 to the x. This is doubling. If you say 3 times 2 is 6 to the x, you're saying you can turn a doubling into like a 6 thing. I don't know what a 6 thing is, but it's not true. You cannot do that. Okay? So let's try and find the y-intercepts on these ones. Gordon said just faster. Y equals 1, 2 to the 0. 2 to the 0 is just 1, so it's 1. We don't write y equals 1, we write 0, 1. It's a coordinate. Then this one is 3, 2 to the 0. 2 to the 0 is 1, so it's 3. 0, 3. And then we have y equals 4, 2 to the 0, which is 1, so it's 4. Y equals 5.25, 2 to the 0, which is 5.25, 0 and 5.25. So if you're just in the form y equals a, b to the x, there's no translations on it, what can you say about a then?
It is the y.
Yeah. So if you're in this format, no plus something at the back, because if I go plus 7, I'm moving it up 7, it's totally destroying your y-intercept rule, right? So if it's in this base function, your a is your y-intercept. Don't worry, the board just told me the temperature is rising, just in case you were concerned. No, that's not what that means. It's just rising from minus 21 to like minus 19 or something. Okay, so this one, I have y equals 1/3 x. What did we say about the 1/3? It
decreased
Yep.
down.
Depreciate, decrease, and down. You were trying to use all of them. It's true. So if I have y equals 1/3 to the x, how else could I write 1/3? 3 to the negative 1. And the reason why is this is 3 to the 1, correct? If I bring it up to the numerator, it becomes negative 1. So I know that a tripling function, one that was like a 3, right, is increasing, yes? If I take this increasing function, the tripling function, and I reflect it in the y-axis, which is what the negative 1 does, it actually makes it decrease. So that's why it decreases, right? It also decreases because you only have 1/3 of your original left, right? Like if my b is 1/3, that means I have 1/3 left. How much went away every time? 2/3 goes away every single time. It decreases by 2/3, 2/3, 2/3, right? Because your depreciating is how far away it is from 1. Your appreciating is how far away it is from 1, right? It's still the same rule. All right, so let's look at this one. If I go to do y equals 1/3 to the x and I fill it in, I'm going to get 1/3 to the -3, which is actually 3 to the 3, which is 27. And then 1/3 to the -2 is actually 3 to the 2, which is 9. 1/3 to the -1 just causes the fraction to flip, so I get 3. 1/3 to the 0. I can't believe you guys aren't answering this quickly.
Oh, sorry. 1.
1. There we go. It's the steady answer previously, and then you guys dropped it off. Okay, and then we go 1/3 to the 1, which is a third. 1/3 to the 2, which is 1/9. 1/3 to the 3, 1/27, and then 1/3 to the 4, which is 1/81, which is really, really, really close to the x-axis. That's what it is. Okay? So if we go to plot these, I'm going to make my x scale be 1. And my y scale be 1. You could make it be something different. I'm going to make it be 1. I have -3 and 20, -20 or 27, which is too far. 2 and 9.
Thank you.
-2 and 9, -1 and 3, 0 and 1, 1 and a third, and 1/9. It's getting ridiculously close, but not touching the x-axis. Try and draw it straight. My board and me, we don't agree. Now it's running along the x-axis. What is the x-axis in this case?
The horizontal asymptote.
Horizontal asymptote. And the x-axis has an equation of what?
1 plus z.
Right. So we actually have a dashed line whenever we have an asymptote. And I'm going to write it as horizontal asymptote. Because it's just a reflection of the tripling graph, right? What's the domain of this graph? Yeah, it just keeps going on this way for life and this way for life. So in set notation, it would be x such that x and m are the reals. In interval notation, it'd be -infinity to +infinity. My range can't equal 0, and the entire thing is above, correct? That's going to be y such that y is greater than 0, y-er. Make sure you don't have the equal to sign, because that's where the asymptote is. Wow, that made my e really ugly. And then it would be 0 to infinity round bracket. Asymptote, so you have a horizontal. Asymptote. At y equals 0. I have a y-intercept at 0, 1, and no x-intercept. And remember we said the way you could get an x-intercept is you have to have some sort of vertical translation, because you need to get that asymptote off the x-axis. As long as the asymptote's on the x-axis, you're not getting any x-intercepts, right? The horizontal asymptote's on it. And remember what I say the horizontal asymptote is the same as yesterday. Vertical translation. So if there's no vertical translation on your exponential function, on your exponential equation, you will have no x-intercept, and your asymptote will be on the x-axis, right? So if you need a vertical translation in order to get x-asymptote, or x-intercept. So 0 is less than b is less than 1. Do you see how it stops at 0? We can't go below 0. 0 is 0%. That means you have nothing left. You can't make yourself have less than nothing left. Like, you can't take away more. Okay? Greater than 1 makes it increase. Between 0 and 1 means it decreases. And how far away from 1 is how much it decreases, right? So even if I had 0.8, it would have decreased 2, right? 0.1, it would decrease 90%, right? 0.01 decreases 99%. But if it's a 0, it means you have nothing left of it. You can't have like a negative something left of it, right? So it's between 0 and 1, it's decreasing, and greater than 1, it's increasing. And what if it's just at 1? It's a horizontal line. It's not even exponential. It's just a constant function. When something's at 1, it just stays the same the whole way. Yeah.
Is your base able to be 0, or is that like...
It can't be 0, because then you would have had nothing to begin with, and you have nothing left, and there's nothing there. So that's why it always says 0 is less than b is less than 1, and the other one says b is greater than 1, but 0 and 1 are not inclusive. Yeah. So this is called a decreasing exponential function or a decay function. What type of transformations occur when you go from y equals 3x to y equals 1/3 to the x? Yeah.
Y-axis.
Yeah. So when you want to compare, you always have to compare with same base. So this is 3 to the x, and this one would be 3 to the negative x. Oops. So the only way you can compare transformations that have happened is if the bases of the two functions are the same. The base appears nowhere in there. You're not like vertical stretch by 3 or horizontal stretch by 3. That base does nothing. It just has to be the same. So the base should never appear in the words of your transformations, just so you know. So because I have a positive x and a negative x, I have a reflection in the y-axis. And here it says, given the point -2, 16, -1, or -1, 4, 0, 1, what function of the form y equals c to the x can be used to describe this graph? I'm going up by 1 each time. My x's are going up by 1 each time, right? So that's what I need. I need to be able to compare by 1 each time. But my y is going from 16, from the left, 16, then down to 4, then down to 1. What's happening each time? Decreasing. And what's left each time?
A quarter of what was before.
A quarter is what's left. So my b value would be a quarter, right? What's my a value?
1.
1, because?
1.
I-intercept is 1. You can't just say 1. It doesn't explain why. Why? 1. Okay. And then we're on to did I print these? I don't think, did I print these for you? Okay, good. So we're on to transformations. Like I said, the only way you can compare transformations is if you have the same base, right? Great thing, transformations do not change. What's in front of your vertical stretch? The back to vertical translation. Flexion in the x. What's with the x happens to be horizontal, and always flips. So you have to make sure you have a 1 in front of the x. All the same rules apply. The only way it's different is on your next test, where you have to say vertical displacement and horizontal phase shift per trig, right? Other than that, we're back to translations. So, describe how the graph of the second function compares to the graph of the first function and determine the mapping notation. Both of these have base 4. We agree? Is the 4 appearing anywhere in our transformations?
No.
No. We don't care about that. We do care about the 2 in front. What is that? And remember, we have to go in the order cert. You agree? So we have vertical stretch. Do I have to write cert? No. I'm proving that. I'm just proving a point. It has to go stretch, reflect, translate. So vertical stretch by a factor of what? Yeah. Of 2 about the x-axis. Are there any reflections? There's no negative here, and there's no negative in front of my x. And I'm only allowed to state horizontal translations if there's a 1 in front of my x. Is there currently a 1 in front of my x? Yes, so then I can state the horizontal translation. I have a horizontal translation. Two to the what? 2 units, right. Always the opposite, never changes. That's the greatest thing about it. So my mapping is the same as my words. So I'm going to have x, y becomes vertical stretch by a factor of 2. So I'm going to get 2y. Horizontal translation 2 right, x plus 2. What do I have to do the next one before I can state it? Okay.
The x needs to have a 1 in front of it.
The x needs to have a 1 in front of it. Sure. And the 4 should move to the right. So we're going to get y equals negative. The 2 can go in its own bracket. 1/5 x. You don't have to worry so much about the 1 being in front of the x because we don't have a horizontal translation. So we could just go 1/5 and then go x, right? And then it has the 1 in front of it. Do we have any stretches? Yes. We have a horizontal stretch. Nowhere, Chloe. It's right there. I have no idea what you're talking about.
I was genuinely just confused.
Well, I was confused. I didn't write it, so I can see why. Horizontal stretch. I appreciate you asking right away, not at the bottom and then asking and I have to try and squish it in somewhere. Horizontal stretch by a factor of? Yes. About the y-axis. Do I have any reflections? I have a negative in the front, so I have a reflection in the x-axis. And I have a vertical translation. I don't like this thing makes me write so dark and so messy. Vertical translation 4 units down. So my mapping would be xy becomes 5x, comma, negative y minus 4. So he wants to state the x and y intercepts of the following. I'd have to use a little bit of vowels at some point. So let's do the y-intercepts first. What's the y-intercept of this one? It's 0, 1, and that's because we can go y, or it wouldn't be a y actually. It would be f of 0 equals 2 to the 0, which is 1. This one I would do f of 0 equals 2 times 10 to the 0, which is 2. This one we have f of 0 equals 2, and then 10 to the 0, which is still 1. And this one I get y equals negative 1/2, 3/5 to the 0. So it's negative 1/2. Now, what are the x-intercepts of all of these? Nothing. Why?
Because it's the big asymptote. It's like the asymptote above the
Yeah, the asymptote is on the x-axis. So I have plus 0 at the back for my vertical translation. I have an asymptote on my x-axis. I have a plus 0, plus 0, plus 0. There are no x-intercepts. I'm writing it along the whole thing. No x-intercepts. My goodness. As the, I think this one's just not, it's failing me right now. No, it's just the horizontal asymptote. Y equals 0 is on the x-axis. Okay, I want you to do example 3 quickly. Explain why.
1 degree. Like actual.
Okay.
Yeah, I remember.
So we have y equals 1/3 x is the same as 3 to the negative 1 x. And then the other one is y equals 3 to the x. And we can only compare when they have the same base, correct? So now we have a 3 to the x and a 3 to the negative x, which means we have a reflection
That's what I did.
in
That explained it.
y-axis.
What's your because statement?
You should use a therefore statement rather than a because. All right, we're actually flipping. Okay, which equation determines the asymptote? Which one's it going to be? A, B, C, or D? It's multiple choice. The asymptote? Oh. Yes. Remember, your vertical translation moves your asymptote. Your asymptote is here normally. If it moves it 1 up, it's now here, which is y equals 1. So, let's think about it. Normally, your domain and range of a basic exponential function, whether it's increasing or decreasing, is xer, right? Now, if it got reflected or stretched, it would still be xer. That doesn't change, correct? But what does change? Your range. So if you have a reflection in the x-axis, which means a negative in front, your range is going to become less than, not greater. So normally it's greater than 0. If I just have a reflection, it'll be less than 0. But it's going to be greater than or less than your asymptote, correct? So it's always going to be greater than or less than your vertical translation. We agree? So a way you can think about it for range, the board lets me write, is if you have a reflection in the x-axis, it causes the whole thing to go downwards, right? Then your range is going to be y such that y is less than the vertical translation. Please don't write BT on the test. Actually write what the vertical translation is, because that's your asymptote. YER. And then no reflection in the x. The y doesn't matter. The y just makes an increase or decrease. No reflection in x-axis. Let's pick up speed. Job board. And my range is going to be y such that y is greater than the vertical translation. Because I said the vertical translation is the asymptote. And the graph is either completely above the asymptote or completely below the asymptote. Right? So we're going to look at 5x plus 4 plus 3. What has happened? What does this 5 represent? the base. So it's actually increasing by 500%. It's not doubling, it's not tripling, it's increasing by 500%. That's what the 5 means. What does this x plus 4 do to that graph? So now I have an increasing graph above 0. What does the x plus 4 do? 4 to the left. Does that change anything for domain and range? Nope. And then what does the plus 3 do? Moves it 3 up. So I move 3 up. Am I still above? Yep, I'm still above, right? And it's, my asymptote's now 3 up. So what's my range going to be? Y such that y is greater than what? 3. Y is an element of the rails. Did my exponential domain change? No, unless it's a word problem, your domain for every exponent is exponential graph, is x an element of the rails. Or in interval notation, negative infinity to positive infinity. And here it would be greater than 3, so 3 to infinity. Now the x and y intercepts. So if I want to do y-intercept, sometimes it's not as easy as it was if you have more transformations, right? Y-intercept x equals 0. So I'm going to get f of 0 equals 5 to the 0 plus 4 plus 3, which equals what? What's 5 to the 4? Is it 625?
Yes.
Plus 3, 628? So my y-intercept is kind of up there, 0 and 628. X-intercept is often where you're going to have to do some log stuff, because you're going to try and get the exponent down. So x-intercept y equals 0. The x-intercept is always harder to find. So we're going to go 0 equals 5 to the x plus 4 plus 3. What's the first thing I'm going to have to do? Subtract the 3. So I get negative 3 equals 5 to the x plus 4. I need to get that x plus 4 down. How do I do that? Log both sides. So I'm going to go log negative 3 equals log 5 to the x plus 4. You can stop right here. You could have stopped earlier, actually. Type log negative 3 in your calculator. It gets mad at you. There's no such value as log negative anything. You can't do a log of a negative number. So this would be the way to algebraically show there is no solution. Also, we wouldn't even have to do this if we know what our graph looks like. But if it's algebraically, you have to prove it, or determine, that would be how you would determine it. You have to show them that it doesn't work. But if you're just actually answering it, you know that you have an asymptote at 3, and the entire graph is above it. So there is no x-intercept. Yeah.
My calculator gave me an answer.
It should. What did you type?
I have no idea what's happening. What?
Oh, it's
Just-
matching.
Oh, is it?
Just throw it across the river. Okay, and then the equation of the asymptote. You have a horizontal asymptote. No, he's probably not.
Way over there.
Horizontal asymptote.
Yeah.
At y equals 3.
I need that for the factory program.
Oh my gosh. Okay. So, your questions to work on. We just did 7.1 and 7.2.
Wait. We're getting questions. We don't get questions a lot.
You know, by heart, you just want to multiple sets. You all have it once.
Six, I just want you to do parts 2, 3, and 4. That is a 3. 2, 3, and 4. And I want you to do 7B.